Okay, the question one is, it's easy because the only thing you should do is look in the graph it's given. Then you see vertical asymptote. Well, it's obvious que es -1. It's equal to -1. Horizontal asymptote. Horizontal. I saw que es at y equal -2 here, over there. Okay, now find the x-intercept and y-intercept. X-intercept is the point in which the curve crosses the x-axis. I saw here que is in -3. So it's the point -3,0. Okay, only one. Entonces, in the y-intercept, only one also is at the point I saw here -6. Entonces 0,6. Get that option. Domain is all real number except the restriction. The restriction are in the asymptote, que es el -1. Entonces es from -infinity, -1, to interval. Union, -1, infinity. However, the range is exactly the same, but in the y-axis. Entonces then you take care the horizontal asymptote because the curve approaches pero never touch -2. Entonces from -2, from -infinity, sorry, -2 union -2, infinity positive. Okay, question 2 is extremely easy because the only thing you should do is graph the vertical and horizontal asymptote. So always you investigate the vertical asymptote, you take the polynomial and the denominator bottom, you force it to be equal to 0 and you solve this. Of course, after any simplification of the whole, but no, in this case, no, we have no whole. So you take x plus 2 equals 0, x equals -2, this is our vertical asymptote, and you plot that. Okay, now the horizontal is a little bit more complicated. Not complicated, but you need to learn some rule. And the rule is the degree analysis. For example, the degree of the polynomial at the top, in this case, is 0 because it's constant. It's just 10, no x, degree 0. And the degree of the polynomial in the denominator is 1 because it's linear. Entonces, when this situation happens, when the degree of the denominator is bigger than degree of the numerator, this is a special case in which, yes, we have horizontal asymptote at always y equals 0. Okay, question 3 is similar. In order to find the vertical asymptote, you take the polynomial in the denominator, que is -x plus 5. You enforce it to be equal to 0. And the solution for this elementary linear equation is x equals 5. And this is our vertical asymptote, and you plot that. Now, again, to investigate the horizontal asymptote, one more time, we are doing the degree analysis. Degree of the polynomial in the numerator is 1, linear. Degree of the polynomial in the denominator again is 1. It's the same degree. When the situation happens, but it's the same degree, to say you, in order to find the horizontal asymptote, you take the leading coefficient, o sea, the coefficient no, the leading term, que es the term que contain highest degree, que in this case obviously is only 1. So you take the dominant and the top is -x, dominant and the bottom is -x, it's the same. By coincidence, not always happen. Entonces es igual 1. Entonces our horizontal asymptote is at y equal +1. And you plot that. question 4 is repetition, the same idea, but the only complication is the degree of the polynomial is 2 in this case. But basically, we have quadratic numerator or denominators are both. It's the same procedure. Look, you take the polynomial in the bottom, denominator. You enforce it equals 0. In this case, you have quadratic equation. And you solving this quadratic equation super easy because it's incomplete quadratic equation. Not necessarily using a quadratic formula, no. Using the square root method, you isolate x squared, of course positive, and take out square root both sides, and the answer is 2 solution plus or minus 2. Actually, you have then 2 baric acid. I plot that baric acid number 1 and baric acid number 2. In order to find out the horizontal, same idea, degree analysis. You analyze the degree of the top polynomial is 2. Degree of the bottom polynomial is 2. Same degree? Yes, we have. Okay, now you take the leading coefficients, term, leading term, que is 2x squared divided by minus x squared. So okay, x squared cancel out. And the answer is negative 2. Negative 2, y equal minus 2 is our horizontal axis, and you plot that. End the story. Okay, question 5. The first part is similar. In order to find the baric acid, you take the polynomial and the denominator, que is 2x plus 3, you enforce it to be equal to 0, you solve for x. And the answer is negative 3 over 2, and decimal is 1.5, negative 1.5. This is our baric acid, and you plot that. However, the other asymptote, que maybe is horizontal or slant, depending of the degree analysis. In this case, the degree of the polynomial and the numerator is 2. Y the degree of the polynomial in the denominator is 1. Entonces, when this situation happens, when the degree of the polynomial and the numerator is bigger than 1, only 1, the difference between them is 1, no more. We have this now, no horizontal. Remember, a horizontal we have when there's the same degree or when the degree of the denominator is bigger. Otherwise, no. See the degree, repetition, see the degree of the polynomial in the top is bigger than 1. The degree of the polynomial at the bottom is slant. Okay, entonces slant is, you know, is oblique line, inclined line. And to find the equation, you perform the division. You divide the numerator divided by the denominator. This is long division. So I don't need to explain this. I suppose it's obvious. And the equation is 3x minus 2. And this is the equation for this line. To plot that, well, this is a line. And the line, you know, have the y-intercept. In this case, negative 2. Negative 2. Negative 2. I forgot here something. Well, no. Negative 2. So I plot that. 0, minus 2. No positive 2. Negative 2. And the slope is 3. And remember, the slope is the ratio between two quantities is called a rise and wrong. Rise is 3, wrong is 1. So you plot 1 point first, okay, 0, minus 2. And from this point, you move in 3 units upwards, because rise 3, 1, 2, 3, and 1 unit to the right. And you plot the second point. You connect in this point, and you have the graphic representation for the slant asymptote. Okay, the question 6 is more complicated because you need to plot first of all vertical asymptote and horizontal asymptote. So in general, they are asymptote. But you need to know that according to the degree analysis, we have horizontal. And the vertical is easy. You take the polynomial and the denominator is x plus 1. You put equal to 0. You convert to equation. And you solve this equation. And the answer is -1. This is -1. I plot our vertical asymptote. Okay, now the horizontal asymptote according to the degree analysis, degree of the numerator is 0, degree of the denominator is 1. Therefore, yes, we have a special case of the horizontal asymptote in which the horizontal asymptote is located at y equals 0. Okay, I plot that. Okay, but we need more information. We need 2 points on each piece of the graph. Totally arbitrary. For example, I select one, positive one. Of course, you put the original equation in your calculator. I did here. I plug in 1, and the answer is -1. That the point is 1, -1, and so on. I plug in 3, or 4, whatever. I plug in 3, the answer is -1/2. And the other side, the other piece, I select arbitrarily -2 and -3, and the answer was in my calculator +2. So the point is -2, +2, and -3, +1. I plot that. After when you plot that, you select the tools que do the graph automatically. See, you are doing well the point. You are doing wrong the point. To say, it's confusing and doing one weird thing that you don't understand very well. Okay, now ready. 7, question 7. It's similar. The only difference is that this rational function has a linear in the top and linear in the bottom. But the vertical asymptote is the same. You take the polynomial in the denominator, is -2x minus 1. You put equal to 0 and you solve for x. It's 1/2, positive 1/2. This is our vertical asymptote. Yeah, I plot that. After that, we are doing the degree analysis. In this case, degree is 1 in the top, degree is 1 in the bottom. It's the same. Yes. This conclusion is confirmed that we have horizontal at the division leading term. Entonces es -1/2. I plot that. The rest is calculated. You put in your own calculator different points in each piece of the graph. So basically, the vertical asymptote split the plane into semi-plane. So you take 2 arbitrary points in the semi-plane of the right-hand side and 2 points in the semi-plane on the left-hand side. I take arbitrary 1, for example, +1. I'm plugging it into the original function using my calculator, of course, and you get -2. Likewise, 4 positive, give me -1. Yeah, done. And the right hand side. And the left hand side, I select -1, because the answer is 4, and -2, because the answer is +1. I plot this point. After when you have asymptote a point, the point you plot as always, using the tools of the pencil maybe, but I don't like pencil. I like this tool that allow me put the component of the point, x, y. Now, finally, you click on the graph function button, this, and that's it. Question A is different, totally different. It's, apply transformation. So it's given one function, one rational function. However, doing transformation, you are doing the new graph after the transformation. Entonces I can see que the transformation is, number one, reflection. Reflection, we respect the x-axis. So you flip that because it's minus 1 over x squared. So this minus indicates reflection with respect or about that x-axis. And finally, plus 2. Plus 2 outside the variable means a vertical shift 2 units outward. Okay, so you move after the reflection in that order, you move in 2 over. In this case, totally irrelevant the order, pero you need to respect the order of operation. The first operation is reflection, and the second is vertical shift 2 units over. And that's it. Question 9. Question 9 is very, very interesting. In this case, the same procedure. You take the polynomial in the denominator, que es x plus 2 equals 0, x equal negative 2 is the vertical asymptote. You know that. The second is, in order to find if we have slant or horizontal, you analyze the degree. Degree 2 in the top, degree 1 in the bottom. Definitely no horizontal. It's a slant. Therefore, you are doing the division of this expression, and you get the quotient, it's a slant equation. The slant equation is y equal 3x plus 2. Entonces, in order to do the graph of this specific line, you investigate the y-intercept is 2. You plot the point 0,2. I did that. Look at the graphic. You need to plot the second point. The second point you obtain using the slope. The slope, remember, is the ratio between right and wrong. 3 is whole number, so right is 3 and wrong is 1. So I'm moving 3 units. So from the y-intercept, you move 3 units over, 1, 2, 3, and 1 unit to the right. And you plot the second point. You're connecting both points by the straight line, and that's it. I have my slant asymptote. Then the complicated part, not complicated but long part, is plugging in two values in the different pieces of the graph. For example, I select 1, plugging in 1 into the original, and give me 10 over 3. You type in like a fraction, no decimal fraction. One more, I select 2, positive 2, and comma 27 over 4. Finally, plot two arbitrary value of the x in the left piece. And the left piece is negative 3, comma negative 2, and negative 4, que es negative 15 over 2. You plot that using the tool que I recommend before, que es the quadrant, in which you specification the component of the point. So when you have the 4 point and 2 asymptote, you press or click on the graph of the function button, and you obtain the answer. Okay, question 10 is more complicated. The reason it's more complicated is because we have the same idea. We have the vertical asymptote, the horizontal asymptote, different point, but you need to keep in mind that we have a hole. How do you know that? Well, you take the original, I copy that. You factorization. So the first thing you should do always is factorization the polynomial in the top, factorization the polynomial in the bottom. See, we have no common factor to cancel out. Okay, no problem. You have no whole. But if you have some factor is cancel out, is gone. Entonces we have a new expression, but you keep in mind that this expression, the new expression, is equivalent to the original except in the whole. So basically, the expression is minus 3x over x plus 2 under the consideration that x is no negative 5, que es the factor que is cancelled. Okay, so to find the vertical is the same. You take the polynomial at the bottom, but not the original. No. You know the new one. X plus 2 equals 0. X minus 2, you plot the vertical asymptote. To do the analysis of the horizontal asymptote, well, so you take the original or the new one. I prefer the new one, que es easier, right? Entonces now the degree is 1, the degree at the top and the degree at the bottom is the same. It is you divide the leading coefficients, que es negative 3 over 1 is negative 3. They plot that. Okay, cool. Now the rest is the famous 4-point, but in this case include the whole. Look, you start by drawing the asymptote, then plot 2 points of each piece of the graph, exactly the same. Finally, click in the function. Be sure you plot the hollow dot where is a hole. Okay, entonces now calculate. You put the function, you replace, substitution, plugging in different value. I select 2, que the answer is negative 3/2. Select 4, que the answer is negative 2. This is just calculate. Select negative 4, que the answer is negative 6. Select negative 6, que the answer is negative 9 over 2. Okay, now the whole. I know that the x value for the whole is negative 5. And you plug in negative 5, but plugging in negative 5 no in the original. Because you plugging in negative 5 in the original, give me undefined. You plugging in negative 5 in the new one after the simplification of the whole. And you obtain negative 5. So the whole is negative 5, negative 5. It's a coincidence que it's the same. No, it will happen, but in this case happen. And you plot that. Finally, when you have 2 point plus a whole, you press or you click on the graph function button. And that's it. Okay, question 11 is easy. Okay, we have two functions, two, G and H. And we need to identify what graph matching better. So let's start for the first one, G. G is 2x squared plus 2 over x squared minus 1. Well, a factorization. And then the top, the greater common factor is 2. And the bottom, we have the differences of the square, a factorization into binomial. In order to determine the vertical asymptote, you enforce the bottom part equal to 0 is obvious. Because the solution is positive 1 and negative 1. Entonces, basically, the clue of the identification is we have two vertical asymptotes in positive 1 and negative 1. Entonces, basically, maybe the graph is BC or F. Okay. However, in order to discard one graph is no good, you take the, for example, the polynomial and the numerator gets 2x squared plus 1, and you enforce it to be equal to 0. In order to find the x-intercept. It's obvious that this equation have no solution in the real field. And no solution means that we have no x-intercept. Okay, so the only graph that is solved, they have no x-intercept, is F. However, double confirmation that we are doing well, you find a y-intercept. Y-intercept plugging in 0, replace x for 0, and the answer is negative 2. But the point is 0, negative 2 exactly we have in the graph F. Super clear. Let's move on to the H. H is 3x plus 6 over x squared minus 50. Again, factorization. GCF in the top is 3. The bottom is difference of a square. And you factor out into binomial x plus 4 and x minus 4. So now you discover that we have two vertical asymptotes, but in this case, positive 4 and negative 4. According to this idea, the graph is A or D or E. Okay, now to discover exactly what is the possibility, you find, for example, the x-intercept. You take the polynomial. No. You seek the factor x plus 2. The corresponding 0 is x equal minus 2. Minus 2 es negative. Entonces the other graph have, o sea, A have negative 2. Okay. However, there are two graphs that have negative 2. The graph A and the graph E, the x-intercept. However, to find the y-intercept, obviously is replace 0, x equals 0, is negative 3 over A. It's a negative small value. Okay, obviously the graph E, because the graph A is positive. So basically is definitely is graph E. Okay, question 12 is similar. We have polynomial on the top, minus x squared minus 7x. Polynomial at the bottom is x squared plus x minus 12. Okay, remember, the first thing is factorization. You are doing your best in the factorization. The great common factor is minus x, open parenthesis, x plus 7. At the bottom is trinomial, open two parentheses. The combination is 4 and 3, because 4 times 3 is 12, and somehow 4 minus 3 is 1, positive 1, cool. So this is the factorization. We have no common factor to simplify. Therefore, my function have no holes. Okay, now in order to find the vertical asymptote is the 0 of the polynomial in the denominator, que es negative 4 and positive 3. I plot that. Two vertical asymptotes. And the horizontal only one, using the leading coefficient, que is minus x squared divided by x squared positive is negative 1. This is the horizontal asymptote. Now the question say the intersect. Intersecting is easy, it's only 0, 0. So you replace x for 0, the answer is 0. So the 0, 0 is both. It's x-intercept and y-intercept. However, you have 2 points in each piece. I select 4 plus the x-intercept. The rest is calculator, plugging in 2, 2,3. 1 is 1,4 over 5. And negative 5 is negative 5,5 over 4. And negative 3 is negative 3, negative 2. I plot that point. After that, you finally click in the graph a function button, and that's it. Okay, this is question 13. This is a little bit conceptual. Okay, you have the graph of the rational function. You can see we have, for example, one is given also two vertical asymptotes in +1 and -4, and one horizontal and y equals 0. And one point is given -5, -1. So I need to identification different possibility, no? Entonces, si we have two vertical asymptotes, es obvio que in the top and the bottom, sorry, we have two binomials, que es x minus 1 and x plus 4. And also, no information is given clear, but I can see in the graph that the graph never intersecting the x-intercept. Therefore, in the top of the rational function, we have no factor, we have just a number. Because it's impossible to be 0. Entonces, in my opinion is the third option, number 3, you know? Because, let me repeat again the idea. Two factors in the denominator, because we have two vertical asymptotes, and no x-intercept. Entonces, I suppose que you don't know A, but you can find A plot the point. The point -5, -1. The x component is -5. You replace x for -5 and y is -1. The only unknown in this equation is a, so for a, the answer is -6. And that's it. So the answer is -6 over parenthesis x minus 1 times parenthesis x plus 1. Okay, this question is just calculated. Don't waste time to do it another way. You put in decimals. You put in decimals that function. I did that. And this is the graphic I obtained. Okay, now basically the first question is using the Aleks graphic calculator. Not good. Aleks graphic calculator is not good. Well, I don't like. I like decimals. To find the x can minimize the temperature of the given minimum temperature, round your answer to the near 100. Because I need to find the minimum. Let's say local minimum of that function. Local minimum have two components, no? X component and Y component. X component and our problem represent the time, because the x-axis is time and y-axis temperature. Entonces now decimals always offer the answer in decimal using 3 decimal places. However, they want 2 decimal places. Well, round your answer to the near 100th. Entonces es obvio que you trunque no, round off. Okay, it's 1.193. If the next digit after the 100th place, the second place, is less than 5, you remove, delete. And the answer is 1.19 years. Likewise, when the temperature is negative 2.193, same thing. Remember, see, the digit after the thing you want to round is 5, greater than 5, you increase it +1. But it's not the case in this problem. So just remove and that's it. Okay, question 15, and the rest of the other question is solution for the inequality. Polynomial and rational. But in this case, polynomial. And by the way, the polynomial is expressed in factorial form. Entonces es easy, no factorization, not necessary factorization. And you determine the critical value. Critical value es de 0, o sea, temporary you suppose que our inequality is no inequality equation, and the solution is -5 -3, and +7. And now, after that, the thing is graphic. You represent graphically all real number line, and you are doing the partition in -5 and -3 and +7. After that, you select inside each interval one testing point. I put in red color, -6, -4, 0, and 8, totally arbitrary inside the interval. And you create the table. You can do the table, or you can plug it in directly in the original expression, but I prefer, I don't know why, the table. Just in the table, have the first column, que is the testing point, TP, and you have 3 columns, 1 column for each factor, and you attach extra column, que is the total, in which you summarize the sign. For example, it's easy, determine the signs. Actually, I don't need the value, I need the sign. -6 plugging in the first case x plus 5 -1. So you don't need to write -1, you put negative also. Okay, so now one by one, row by row, I prefer. So -6, negative, 3 negative is negative. -4, positive, negative is positive because you have 2 negatives. So the super easy way to determine how, si it's positive or negative, you count how many negative we have in the row. We have 2, que es even number, entonces es positive. You have 3, que es odd number, negative. 0 is plus and minus, 1 negative is negative, and 8 is plus, que es plus. Entonces, according to the inequality, is greater than or equal to 0 is a positive. So the solution, so the testing point que pass the test is the testing point que have positive in the total column. Entonces es -4 and +8. And you highlight this interval. Now the endpoint is extremely important. Entonces now the endpoint is dependency. Our inequality is a combination inequality and equation. So it's greater than or equal. Entonces now the endpoint is included inside the solution. Entonces bracket. Entonces bracket -5, -3 bracket union bracket 7, infinity parentheses. Okay, again we have polynomial, but it's the different type because we have one factor squared. Yeah, I know very well that this factor x minus 1 squared is always positive or non-negative, positive or 0. That is a reason that allow us delete pero partially, not totally. Partial delete x minus 1 factor, so you copy now the new equation, the new inequality, sorry, que es x plus 2 times x minus 3 less than 0, and under the consideration que x no 1. Because this is 1 is 0, and 0 is no less than 0. So you need to exclude this value. Okay, so now I do the line. I split the line using the critical value, in this case -2 and +3. And you taking, don't forget, in 1 we have a hole. Very important, this idea. And you maybe select 4 testing or 3. Actually, much better for me is 4. And you split the part is separated by 1. You separate in 2 pieces, just in case. Now I create the table using -3, 0, +2, and +4. You plug it into the each factors, and you determine the total, and you see now what is negative. So because my inequality is less than 0. Es obvio que 0 and 2 pass the test. Now I highlight this. Y es obvio que es only parenthesis, no bracket, because it's no equal. And no also include 1. This is also inequality, polynomial inequality, already factored out, factorization. Okay, however, this is different because we have one factor que es irreducible quadratic, que es x squared plus 9. This factor always is positive, not zero. Therefore, you completely delete of the inequality. Totally delete. Because it's always positive. Never zero. Never negative, of course. Always positive. Now, this inequality is equivalent 100% to the second line, que is x plus 1 times x minus 5 alone, less than or equal to 0. We have critical value in -1 and +5. Get the solution for the equation. We're doing the partition, so the critical value always is using to make a partition of the all real number line. Now you select 3 testing points in this case, in each interval, -2, 0, and +6. Now you create a table, you evaluate inside one by one factor, you determine the sign, and you see that the only testing point that passed the test is 0 because our inequality is less than 0. You highlight that, and of course you include -1 and 5 inside the solution because our inequality is not strict inequality, it's a combination inequality and equation. Therefore, the critical value belongs to the solution. Okay, this is the last problem of the polynomial equation. The difference in this example is that you need to manipulate first some algebra in order to express it in the standard way that we need, that the right hand side must be 0, and separate the polynomial in different factors. A factor 4 and right hand side 0 is the very convenient way to start. So well, you apply some basic algebra, you move everything to the left because I need right hand side 0, and you apply factorization by grouping first. After you apply the difference of a square, and entonces we have in this moment 3 factors, x minus 4, x plus 2, y x minus 2. You determine the critical value, que is -2, +2, and +4. You are doing the partition and the all real number line, and you determine 1, 2, 3, 4 testing point, -3, 0, +3, and +5. You create a table, you evaluate one by one in each factor, and you determine the total sign of the multiplication, que is something like that. Entonces now the solution corresponds with the -3, the interval que belongs -3 and +3. Okay, entonces I highlight this interval, but I put in the endpoints bracket because our inequality includes equal sign. So therefore the critical value belongs to the solution. Okay, this question 19 is the first question of the rational inequality. But this is super easy because the right hand side is already 0. Entonces now you determine the critical value, que es obvio que es -1 and -6. Be careful with the sign, guys. Because -1 minus 1 equals 0, es obvio que the solution is -1. Well, if you isolate properly here. And this x plus 6 is clear que es -6. -1 and -6 is the critical value. Make a partition. Selection now the testing point -7, -2, and 0. Remember, it's totally arbitrary inside. And you create the table and you evaluate one by one inside the factors. And you get que the positive is only in -2. O sea, the testing point que pasa the test es -2. The rest no. Okay, entonces the solution you highlight is in between -6 and -1. Of course, parentheses of because our inequality is strict inequality, no equal sign, never bracket, always parentheses. Okay, the question 20 is the last one. It's another example of the rational inequality. However, the only problem is the right hand side is not zero. Therefore, you need to create the right hand side zero always to start. When you move one to the left, you find so you express everything using the common denominator, que is x, so the least common denominator, que is x minus 2. Now, you manipulate this algebra, que suppose que es easy, you understand very well. And we combine like term. Entonces, definitely, in the top we have x minus 5, and the bottom x minus 2. And this is my inequality. Exactly the same with the previous example, okay, the right hand side is 0. The recipe is okay. Critical value is 5 positive and 5 and 2 positive. Create the partition, selection the testing point. In this case, I select 0, 3, and 6. Create the table to evaluate the signs. I obtain 2 positive signs, okay, highlight. So basically, the solution is from negative infinity to 2, not included 2, because remember our inequality have no equal sign, and from 5 to positive infinity. Okay, nice.